And in this video, let's make a back support for our office chair now. And I think this will be a little bit more detailed and long than our previous videos, but we'll end up with something really cool. So to start on our seat back, let's visualize an imaginary finished product. And we're going to create some planes that will go through the cross sections of this imaginary finished seat back. And on each plane, we'll sketch out the cross section of what it looks like. And then we can loft between all the cross sections to actually make this. So I've determined what planes that I want, and I'll start by highlighting my ZX plane. And we'll go to create plane up here. And we'll offset a distance of 5. There you can see a distance of 5. We'll select our geometry again and offset a distance of 20. And then we'll select our plane again and offset a distance of 27. And select our geometry again. This time we want 33. We'll do another one at 39. We'll do another one at 40. And those will be the planes at which we'll make the cross sections of our back support. And then we'll do a loft. So we'll grab this plane first, our ZX plane, and I'm going to start sketching on it. What I'll do first is make a line. In fact, we'll make a vertical line. Make sure that it is coincident with our origin. We'll give this a dimension, right? I want the base of this to be offset from the origin at a distance of 0.25. And then I want the overall length to be about 0.915. Next, I'll do an arc right there. And we'll make sure that this arc center is vertical with its endpoint, which as you can tell it is, because we've already got that constraint on there, which should be that little perpendicular constraint. So because the end of this arc is perpendicular with this line, we know that this arc center will never vary from being vertical with the origin. Next, we'll give this arc a radius, and we'll give it a radius of 58, right? Relatively large radius. I'll probably constrain this horizontally from the origin at a distance of 4. And then we'll give this a tangent arc, and then another tangent arc where we can come back around, and another tangent arc where we go back to the line that we started from. So everything's all tangent, but I do want my arc center here to be vertical with the origin. So we'll grab the origin, we'll grab our center here. And I want to make sure that this is, tangent to horizontal at the end. So I can do what we've done in the beginning here and create that little perpendicular constraint, and that takes care of that. So where are we with our degree of freedom? Of course, we want a radius value on this arc, and we want to position its center. So we'll give this a radius of 1. Of course, that did not quite turn out the way that we wanted it to. So I'll just give this a little adjustment here. And then we'll give this a radius of 1. That's better. I'll also give this a horizontal distance. 9.25 would be a good target. And then finally, we should ask ourselves, what distance vertically are we looking for, and what radius value should we give this arc? So we're going to say 7.13, and we're fully defined. So this will be our seat back to start off with. You'll notice I've only drawn half here, and the reason is we can always mirror the loft after we're done. And that will save us a little bit of sketching effort or mirroring. So we'll deactivate the sketch. We'll create a sketch on the next plane. And as we sketch here, let's make something kind of similar to our last sketch. Now I am going to move this a bit forward. So we're going to make it coincident right on the origin and move straight down. And that way the seat kind of pushes into the bottom of your back, as many office chairs do for comfort. So I'm going to grab my dimension. We'll give this 0.915. And then I'll go with a regular arc. And what we can do is we can say, I want this arc to be perpendicular to this vertical line. And that means that the arc is going to end completely on a horizontal. So it's an easy way to work with arcs with the perpendicular constraint. Not all platforms do that, and I really enjoy that, being able to use that constraint here. I'll grab the center point of the arc and draw another arc on it so that they're concentric. Just like that. From here, I'll make another arc, and it'll go part way around. And then I'm going to make a tangent arc all the way over here. There we go. We'll make sure that they end on tangent. That way we get a little bit of varying thickness throughout the part of our seat. So perhaps I want my profile to be about there. We'll grab a dimension and establish a horizontal dimension of 9.5. We'll give this a radius value of 0.75 so that it gets to be a little bit tighter of a radius than what we had in our last sketch here. I'll give this a radius of 20. And then from here to the origin, we'll give it a vertical dimension of 2. It looks like we are fully constrained, so we'll deactivate that sketch. Then we'll go to our next sketch and activate on that. So we'll make something that wraps around the person sitting a little bit better. I'll make a vertical line. Again, we can use the constraint, or the coincident constraint rather. I'll select the line, select my origin, and now they're coincident. And we're going to have it move a little bit back. So we're going to go behind the origin about a distance of 1.5. We'll give this also a distance of 1.5. Now let me draw some arcs again. And I'm going to have them both be perpendicular to this line. In fact, I can even establish a horizontal between their centers, and that also forces them to be concentric. So no matter how I edit these arcs, they'll be concentric. It's the equivalent of adding a concentric right there, right? It's just comes with using geometry and knowing what our constraints mean. Next, we'll go with tangent arc, there and there. And we can also make those concentric, and of course the concentric relation between two arcs implies a constant thickness throughout the profile that we're sketching, which can be a very helpful thing when we need it. I'll add a tangent from here to there. Next we'll give some dimensional values. We want this arc to be 6.5125 about. Let's ask ourselves how far we want this to wrap around the user. And actually that's pretty close, so I'm going to drag it down further, right? We want it to wrap around quite a lot, like a real bucket seat. So I'll grab the origin actually, and from the origin to this center we'll go with 4 inches. Next I can make this have a horizontal distance of 5. And then of course we ask, where are we not constrained? And it looks as though we just need to assign a horizontal value as to how far we want this to go. Or likewise, we can also say we want this to share the same curvature as the sketch before. We can always import geometry from the sketch before and create a sketch and maintain a source. And there we go. Now that we're concentric, we have a fully defined profile. Now the next is possibly the easiest sketch we're going to do. Let's jump onto this plane. We'll project a sketch, and of course I want to do my last sketch, sketch 3. We'll maintain figure type and association, and we're done. So I want to have the same profile in 2 places, and then we'll add to the next sketch, and this one we'll start to calm it down a little bit. And what I can do is import some geometry, say from our previous sketches. I can import, say, this line, there and there, and we'll maintain association as reference figures. And from here, you always can import these as reference figures and that line as a driving figure as well. But now we have the luxury of being able to make an arc. There's our center. And just having these points right before us makes it so much easier to sketch, and with much fewer dimensions required, as long as our design intent allows for that. I'll go with a tangent arc there to there. we'll go with tangent. And now the only degree of freedom we have is this 1 degree of freedom. And we can choose our origin, choose the center, and say horizontally we want this to be 7.35. Done. Let's do that again. Right here. I'll stand on sketch 5 here, just to remember what it is. Sketch 5, create sketch figure with maintained association to source entity. I can draw a line there. And I can make an arc. And we can set the arc to be concentric. And that's, of course, in place of drawing it over another arc center line. Same result. There to there. Concentric. An arc from here to there. Very good. Tangent. And tangent. And our only degree of freedom is this one. And we just did one that was 7.35, so let's continue to narrow the top of the chair and make this something like 5. We'll deactivate the sketch, right? So you can start to see the outline of a bucket seat that we've created. Let's go to this top plane. We're going to make one more, and we'll make it even smaller. I can project my last sketch as a reference figure with maintained association, of course. You also have the option to right-click and convert to regular figures if you'd like to do that. Many ways to get the same thing accomplished. We'll give this concentric. There's our arc. We'll also make this concentric. There. And there. And again, our only degree of freedom. So we'll go with a horizontal. And we're going to make this 4.6, even smaller. So now it's left up to us to loft this profile and see what this bucket seat is going to look like. We're going to grab loft here, and I'm going to start with my first sketch and come up to this one. And we've got our yellow preview. And then I'm going to go to the next sketch, and you'll see that we've got an error here, right? When the button turns salmon, then there's something wrong. And one way to troubleshoot this is to say OK, and you might see an error box. If not, you can always right-click on your loft and say status, and it says that the operation feature results in an invalid body, and that can happen for so many reasons. But one easy solution is to change the twist minimization. And right now we're on angle, and I'm going to change this to center of gravity. And there we go. We're back in business. I'm going to click on the next loft here. And there. And there. And there. And I think I like the way that this looks like half of a bucket seat. But maybe I'll start off with a tangent here. We're going to say a tangent magnitude. Let's see if 20 is enough. Yeah, I like that a lot. So we have a tangent magnitude of 20, and we bend outwards. Very good. That's exactly what I was going for there. Now, it's also important to note that we don't necessarily need to do it that way. We also can use guide curves, although I just opted to do a pretty natural loft without guides. But always remember that when you are looking for a really precise loft, guide curves can go a lot of distance in helping you out. So next, I think an easy thing to do would be to take a look at what our chair looks like full on. So we'll grab our loft, we'll mirror it just like that. As you can tell, I think that's looking like a pretty good gamer bucket seat chair. I'll grab the top here, and we'll simply add a fillet. And it actually looks like 0.5 works pretty well, but I'll up it to 0.575. So a nice rounded top. And we'll probably want to make some harness cutouts. That is pretty typical among chairs like this. So I'll grab my XY plane and begin a sketch. And I'm going to sketch out, I guess you'd call it a quadrilateral. And we will probably dimension this and then add some sketch fillets in when we're done. So I'll first start by dimensioning off of the origin. And down here we'll give this a distance of 1.6. And then off of this line here we'll go 1.25. I also can establish an angle if I'd like. Maybe we'll call that 65 degrees. We'll grab from here, from the origin, we'll make that 5.5. Maybe we'll give this a slight angle off vertical. Maybe 4 degrees. Now harness is probably should be flat, but this probably isn't going to be seeing a car anytime soon, so we could probably get away with a little bit of artistic compromise there. So where are we not fully defined? It looks like we have a few other vertical dimensions to assign. So what I'll do is grab maybe from here to here, and we'll say about 7.75 to establish a height. And then what angle do we like? And I think I'll probably go with another angle. Maybe kind of a radical angle over here. 65 looks about right. Now we can add some sketch fillets. There. There. And of course the sketch fillet removed a little bit of our sketch geometry, but it's not too big of a deal. So we ask ourselves, where are we not fully defined? And of course it's side to side on there. And we'll define it that way. We'll deactivate, extrude cut, and I'm just going to say through all for the design intent. And we also have the ability to mirror that cut. And we'll select a mirror plane here. Next, I think I want to round off some of these sharp edges. So we'll grab a fillet, just like that. And our previous 0.575 dimension seems like it works pretty well here. We'll apply that and just see if another fillet will get that to work, and no problem at all. All right. So let's also extend this face down a little bit further and shape the bottom a little bit. I'll start a sketch over here, and we'll project a sketch, and I'll import this edge as well as this with maintained association. We'll deactivate and extrude. So I may want to extend this a little bit further down and shape the bottom of this seat back. And to do that, I'll go with the Move Face option. So I can select my faces. Maybe I want to move it down an inch. And you can do that, or maybe an extrude boss, but this is a good way to showcase a whole nother feature. Maybe we can move it down 2 inches, right? Or we can move it down 5 inches. So Move Face is a reasonable time-saving way that you can change geometry, especially if you've created something that has a long history tree and you need a slight change but don't want to go through and redo an entire tree to make some simple adjustments. But here, we've been able to extend this face downwards a very good amount, and I've been able to do so pretty easily. So keep that tool in your back pocket when you need to make some quick changes. Next, I will choose an arc. We'll make the arc vertical, so the center is vertical with the origin here. And let's make the ends distance of 25 apart horizontally. We can also give this a radius, and I'll give it a radius of 50. Just like that. So make those ends horizontal there. That'll make it easier to deal with. Then I can grab a coincident and choose my origin and choose this and stick it right there. So we'll go vertical here. And then I can give this something like 7.75. So now I can shape this bottom with a simple extrude cut. And I can also add a fillet along the bottom. I might think of something like 0.4. Just like that. Even 0.4 might be a little bit large with how we've done it. Maybe I'll go even smaller. One of the things to watch for when we make fillets is that you can see that these faces sort of overlap a little bit. And that is the computation behind what Alibre does. It tries to make these fillets work, but sometimes you get these weird overlapping faces. And if we ever wonder if our geometry has integrity, we can always choose this inspect and check part, and we'll go with a very high accuracy. And it tells us that a few things have failed. Faces, edges, and vertices, right? And these are things that we just want to watch out for potential errors. And so, of course, that's the fillet that caused that. And so I'll go even smaller, maybe 0.3, and see how that looks. And there you can see we have one consistent bottom face, and the fillet isn't overlapping with itself like it was before. I might even be able to go a bit larger. I like that a lot. So we'll say OK. We'll check the part at a very high accuracy, and then we'll say apply. And of course, that made no fails whatsoever. So we know that we have good geometry when we're making this. And I'm saying that that is starting to look like a pretty comfortable seat back. Now, one of the last things to do, let's create a flat face on the back that would allow us to bolt into a bracket to implement into the rest of the seat. For that, I'll create one more plane and I'll offset that a distance of 0.3. And I'll put a negative sign in there so it goes the opposite direction of this arrow. And with that, I can start to sketch here. And I'll reset my view so I'm looking at the back of the seat. And let's go with a rectangle by center. I'll make this about 4 1/8 wide, tall. Let's go 4.5. And then I can add a horizontal so it'll stay put. And I'll deactivate and we'll extrude cut. I'll have this go the other direction. And we'll say OK on that. Next, I can activate my sketch. And I'll make 4 circles that will make all equal sizes. Next, we'll go with a symmetrical constraint. And I'll pick my axis of symmetry. Circle and circle. Same thing here. I'll add a vertical constraint between the two circles. And we'll give this a diameter of 0.5. We'll give each of these circles 1 inch gap here. And then off center. We'll also go 1. And lastly, I'll give it about a 0.6 height. Deactivate and extrude. And there we have it. Holes for bolts to attach our seat. Now lastly, when I look at this straight on, I think maybe a bucket seat ought to be a little bit more swoopy or curvier. And if it hasn't been made clear yet, I hope that this will really emphasize the benefits of parametric sketching. What we can do is I can come in here and say, I want this to be narrower. I want this to be something like 8.5. I can deactivate that. And then I can go to my next sketch and say I also want this to be narrower, maybe 8.75. And then I can generate to the last feature. And now we have a different shaped seat that's a little bit more curvy like we want. And we can run down the tree and see that there's no errors. So we can make early or late adjustments as we need just by editing the tree. And that is how we make the chair back support, probably the longest to model in the whole chair series, so congratulations for getting through it.